can deploy said API to the cloud in roughly 2 minutes. Right, so why GraphQL? I know probably half the room says already it's awesome. I already know all the arguments, but for argument's sake, let's kind of mention why it's awesome. How many of you are using REST APIs? SOAP. Any brave hands? No? You know what I'm talking about, right? XML, not the actual SOAP. I kind of did that joke the other day at work, saying that some people probably don't know anything but JSON. Anywho, GraphQL is about content negotiation. It's about telling the API exactly what you want. It's a bit like an API version of SQL. Some kind of language we're able to specify exactly these columns is what we want. And that means that we are preventing something called overfetching. We don't get a lot of columns, a lot of extra data that we never asked for. That's obviously awesome on a very bad network connection. Yeah, so the whole point of GraphQL is to stay on top of things. You might live in a data landscape where you have tons of different services. All of those different services, of course, talk a different kind of protocol, or there is a different way to access those services. And of course, your data might be spread out all over the place. So your challenge, if you don't have GraphQL, is actually to remember all of those protocols and remember exactly where is that data that I need. Now, so GraphQL would become the front end of the back end, if kind of that makes sense. We can't use it for everything. It's very tempting. It's a new technology. We want to do that. Everything is, the best thing since sliced bread. Am I right? Yeah, so we put GraphQL on top so we don't have to worry about everything that's behind it. So you can, as a app developer, just say, I want to talk to my GraphQL layer. I want bits and pieces of information. I don't care where we have it. I want to speak in JQL, the GraphQL query language. And that's going to save you a ton of time. Obviously, the first time you build your GraphQL API, you're not going to save that much of time because you're going to spend some time building the API. But in the future, all of the other apps is going to save you a ton of time. And you're going to have happy users, even those on a really bad network connection, because you're not overfetching. You're just fetching exactly what you need. Right. We're also going to talk a little bit about serverless. This is just an intro slide. I saw a few hands, but I wanted to say this about serverless. Serverless is cloud-native code that runs for a reason. Something has occurred, and that something triggers your code to run, which could be someone touching an endpoint, or there's a new row in a database. Some kind of important event has happened, and you should do something. Exactly what, that's obviously up to you and your company. It is managed, which means you don't need to care about virtual machines. You don't need to care about app servers and all that, jazz. We only are allowed to focus on business logic, which is what we want at the end of the day. And as I said before, it runs in the cloud. Kind of nice definition, right? Lots of promises of saying, oh, this is the next great thing. So yeah, again, why serverless? Low cost. How many here are using serverless because of low cost? Okay, a few hands. We should know that regardless of cloud provider we are using, most of them are going to offer you a very good deal on serverless, which means that they're going to charge you by invocations in the millions, which means that if you're a startup, if you want a prototype, you could probably do 1 million plus executions with no cost. It runs the code when it's needed. It's not up all the time, which also makes it really, really cheap on the cloud. It's easy to talk to because it's already in the cloud, and all of those great cloud vendors are probably going to make it super easy for you to talk to queues, databases, whatever else services you might have in the cloud. And the focus is on code, as I said. No more virtual machines, no more web service that you need to configure. That's managed. Now, GraphQL, for those of you who haven't seen it. What we're looking at here is first off our query. We use curly braces. So how many have used SQL to do any kind of querying towards a database? It's quite easy to understand GraphQL from that aspect. And if you haven't used or talked straight to databases, remember this, curly braces is the thing. The first thing you mentioned inside of that curly brace is the resource you want. Once you specified what resource you want, you have to specify what columns you want. Unless, of course, in this case, it's a primitive, because that means that we don't have any columns under that thing. So in this case, we see type query on the left, on the top left, and we can see that it's of type string. That should be a capital S, by the way, if someone knows GraphQL, not like me. Sorry, kidding. Anywho, here you got the query keyword that we use when we write our resolver object. So this kind of looks different depending on what kind of implementation you're doing, whether it's Express GraphQL or Apollo. Point is, query is your public API. In here, you're putting everything that should be exposable that you could be able to query for. There is another reserved keyword that makes out the second half of your public API. That one is called mutation. We're going to come to that one. Now, looking at the answer here to the bottom right, we can see that when we ask for hello, it goes down here and says, how do I resolve hello? Okay, it's a function I'm going to invoke. Once I do so, I get some kind of hello world back. It's very easy, right? So what about custom types? Of course, we don't want a very simple API like hello world. We want something real. And this is when I want you to think about databases again, because it's a very good analogy. You're able to compare like a table in a database to types in a GraphQL world. So here you got a type person, you got an ID with a name, an address, and a speaker. As you can see, this is more of a complex type. It's not a hello world, it's not a hello, of type string, but rather of type person. Then we are using this very type in this second exposable property that we have, person. So suddenly we can query for person as well as hello. I was kind of wondering if it was a train, but it's actually the mic. Okay, in case you're wondering, we're not being run over. All right, so that's about that. Let's talk about list types, because of course we need to support some kind of list type. List types are as simple as square bracket. We just say that, okay, we want a new kind of property here called people. It's an array of type person. And looking at our query here to the right, we can see that we need to resolve this in different ways. Hello, we resolve that with a static string. In the case with person, we gave it an object back. In the case with people, we of course need to give it an array back. Make sense so far? Great. Strong beer, I think. Anywho, let's have a look at query with parameter, because of course we don't want to do select star, right? We don't want to select every single query. So we need to be able to narrow that down a bit. We do so with parentheses, and we can do it like so. We say if we query for an ID, the exclamation mark, by the way, means that it's mandatory, if someone wonders what that is. And yeah, the querying here to the bottom left kind of looks like so. So we do get person, we give it some value, in this case 1. And because of the way we define it here on the top left, we say that the return type should be of type person. So every time we get something complex back, we actually need to select what from that complex resource should we actually select out. So in this case, we have selected name, but we could easily extend that and say we want name, address, and a lot of other properties that's on that resource. The point is, if we say there should be a resource back, this would not be a valid query unless we tell it what columns that we ask for. Right, and here we can see in our resolver how we are able to dig out the ID from it, and we do people find, which essentially just narrows out the exact person that we want from that list. This is all very static data, but I'll show you how to make that more dynamic. Query with, well, am I still here? Sorry. Mutation. This is the other half of the public API. I said query was the first half. Query meant that we're only getting data, right? Whereas the mutation means something else. It means changing data, which could be creation, updates, deletions, and so on. So here in the mutation on the top left, we say type mutation, and this is the way that we actually talk to it. Sorry, I'm a bit tired. Should have gotten more beers. Type mutation, this is part of the schema. What we're saying here is that what public properties exist. So top left is the schema. We say that add item exists. we say that add product exists. So what is the difference between these two? Can anyone see it? All right, I'll tell you. Add item takes a primitive in, an item of type string. For complex types, such as the product, we need to use something of type input. So this is an important thing we need to know about in GraphQL. As soon as it becomes complex, we need to change from this primitive to something of type input. You're going to be getting all these slides. You can look at them in your own pace. Yeah, as for calling the mutation, we can choose to opt out of giving it a name and just saying mutation, some kind of name if we want, and exactly what mutation we're calling. In this case, we're calling add item, which means we're going to create something. The moment it's no longer optional is when we have two different mutations, so we don't know which one to pick. At that point, we need to specify them by name. So as long as you have one, name is optional. Right. So as for resolvers, well, we just add the part here at the bottom where we say mutation. With the mutation keyword, we say add person. As you can see, we're able to dig out whatever someone is posting towards us, and we're able to say, well, we need to wait to store that to some kind of data source. And there's another important bit I want you to know about. This is, for me, the thing that really sells GraphQL to me, nested queries. It means that we have some kind of query and we're able to dig down. We're not just on level 1. So level 1 means that we're asking for ID, for name, and for address, a lot of other properties. But now we can suddenly drill down. So we can go to friend and say, friend is a complex. So we go to friend and say, we want your name. Of course, you're probably thinking, okay, that's a very advanced SQL question. Probably need to do some kind of left join, inner join, something, right? Yeah, you need to solve that on the query side of things. I'll show you how to do that if I got some time. Otherwise, we'll be here all night, right? Anywho, let's have a look at what the data looks like, because that's a really important realizer for how we resolve these nested queries. Because if we look at it, we see that we have something called person friend. So now, friend as a property exists on the person object, and it's a complex. It's not a primitive. It's not a string. It's not an ID, but rather an object. When something is an object, we should actually store it data-wise as a primitive. You're like, what? You said it was a complex. Why should it be primitive? Well, this is about lazy loading. This is about not giving the user more than he actually needs or they need. So by saying data-wise that this is a primitive, if they actually ask for this, then, only then, can we actually help them and say, your two probably corresponds to an actual object, so we should do a lookup. Which is exactly what we do here at the bottom. We go in here and friend and say people find based on the ID. So we're actually doing a lookup here. This is part of the problems with GraphQL, because if you allow for this nested thing to go on to 10 different levels, you can just imagine the number of different nested calls that we're trying to do. That's a little heads up with GraphQL, is that you should probably not allow nesting to keep going forever, but probably limit it to second or third level. Feels like I'm telling you all the bad things, but it's very easy to say a new technology, it's awesome, it's sliced bread, but in reality, everything has limitations. This is one. Nesting is all right. Don't allow it for, n+1. That's all I'm saying. Right. So what about building our GraphQL API? We kind of know the basics, maybe. You kind of are with me in this super speed. Here's a schema. In that schema, we're kind of defining different types. I've got a workshop actually for this that's completely free, so you can definitely browse at all the working code there. I'm just going through this at a somewhat heightened speed. We got different types. We got type product, type review. We got a product input, and we got a mixture of mutations and query, which means it's a full-blown API, right? A CRUD API. Then what? And of course, we define some resolvers with some static data. We got a list of products and a list of reviews. And if you got your eyes with you, you can see that we have something, of type product. This one looks like primitive, but it will actually result in actual object. And of course, we got a bunch of functions that has the ability to resolve all of these things. So what about the demo of getting this to work? Well, here we are looking at us having installed Apollo server. We are defining different custom types, input type, mutation, query. So here's our full schema. Here's our full half of our GraphQL server. And yeah, so here is us trying to resolve this. It's a bunch of code, as I said before. This is on GitHub. The whole point is to take the schema, take the resolver. Those two together makes out your full API. And once we have those two halves, then we can merge them and we can actually run this completely. Let's see if I remember what the script was, right? So we're looking at a bunch of things. Those are query, those are mutation, and also the ability to resolve the nested bits. So server listen is what actually creates our Apollo server, our GraphQL server, that's now exposed once we run this on port 4000, if I remember correctly. Yeah, so let's do an npm start, and that means that we are ending up in a browser, and we can easily follow that link. And yeah, this is great, right? We have a visual environment, so we can test out our API. It's running with autocomplete and all the lovely parts. And we can test out this simple query here at our top left, which asks for hello. And we also have a secondary query in which we say we want hello, we want products, and we want reviews. All of this works really nicely, but of course it's kind of static data. Okay, so our end result right now is that we have some kind of GraphQL API on top of a bunch of static data. We have products, we got create product, review, hello, and reviews, which is a different type of data source. Microservices is another thing. So why am I talking microservices when I'm talking GraphQL API? Well, as you might have noticed initially when I talked about this, we talked about a very complex data landscape, right? We got different kind of services out there, all talking different protocols. So microservices is really the reality I think a lot of you are living with. And my point I'm making here is that GraphQL is the layer on top of all of those microservices. Because what the end result for you is to build an app that don't care. It doesn't care whether you have 100 microservices or 2 or even 1. And of course, with the microservices, we're going to talk about containerization. What does that mean? We're going to, well, how many use Docker? Okay, you are believers, right? Anywho, with Docker, we have a Docker file. We are able to create an image from that. And ultimately, we're able to create a container which contains our code, environment variables, a lot of libraries, and a lot of other goodness. So our microservice, by definition, is some kind of self-contained or should be a self-contained unit that has its own data source and its own business logic, right? It should be separated from all the other different services. And it is the opposite of a monolith, which contains everything of everything. We will containerize 2 different services, which means that for every service, we will have a Docker file and an app file, and ultimately we will have a Docker compose file. That's the big orchestrator. That's the one that's going to say, I don't care if you got 2 services or 100 services, I'm going to build all of those, and I'm going to make sure that each of them gets an endpoint. You're going to see how that works in a demo. But first off, this is the instruction file, the recipe file for your microservice. So here you're saying some kind of base image, you want to base this off, and then you're saying some kind of work directory, it really depends on where you work, right? And you also say, well, there's going to be some kind of port, and I want some command here that kind of says I want to copy my application files to somewhere in the container. Then I want to run some kind of command, in this case npm install, to install a bunch of libraries that my service is dependent on. Then I'm exposing a port, and lastly, I'm telling it, how do I actually get my service up and running? So this is all your service might possibly need in the universe. Some kind of base image, libraries, the application code. All of this is a recipe, right? From that recipe, we're able to bake a cake, which, well, is an image. Once we have an image, we can build a container. Looking at the code, it's pretty simple stuff. It's just an Express server that's running on a port with a simple default route and us just returning back a static list. That's the review service. Now we have a product service, and it's very simple, that one as well. But yeah, it looks a bit smaller because the list is smaller. But it's the same idea, an Express service that just exposes a REST API. The file structure after these two services is a Docker Compose YAML file. That's the one that the Docker Compose is going to read from. We got two different directories. Each of those directories contain everything they could possibly need, which is your Docker file, your instruction file, your app code, and some kind of package JSON. And depending, of course, I'm at the JavaScript meetup, right? But if I was at the Java meetup, that would be, some kind of configuration file, a manifest file that says what libraries does this service need. All right, so we got a file structure. We kind of understand this bit. Now we got a Docker Compose. And in the Docker Compose, we kind of specify our two different services. In this case, we're saying, first, the context. Where can I find my Docker file? Because that might not be at the root. Then I'm saying some kind of port mapping. So I'm saying external port, internal port in the container. And for the next service, I'm saying, okay, similar scenario, find the Docker file, do some kind of external port mapping. And yeah, in both cases, we're saying you should be in the same network. That means that they are able to talk to each other. Once we got all this, then what? Well, we got some Docker Compose commands that means different things. How many have used Docker Compose? Okay, quite a show of hands, so you know what I'm talking about. Once you use Docker Compose, that means that it's going to build and create containers for you, and they're going to be up and running. Docker Compose build is just building. Docker Compose down means that we are taking everything down and we're even removing it. This is a really great tool for handling a bunch of different services. Now, looking at the demo, it's quite simple. I think most of you have used Docker, but still. Yeah. So we're just looking at the Docker Compose file, just what I showed you on the PowerPoint, and our products catalog with an app.js of all our app code, our Docker file with all the instructions for how to build the service. See if I can fasten this up a bit. Right. Same thing with reviews, contains app.js and a Docker file and a package JSON. All very interesting stuff, right? Really depends on the crowd. Sometimes somewhere people are building monoliths, so you're a bit more advanced. But here we have our Docker Compose file, which kind of specify both our services, how to build them, how to port map them, and do all the other interesting bits. Now we're just calling Docker Compose to make sure that we actually build those two services, because seeing is believing, right? Otherwise, I would just be some guy that shows you slides and say, it works, I promise. So now we got two different services running, and having a look at those in the browser, just in a sec. There. Now we can go to port 8000. We see that we got a bunch of products. We shift to 8001, and we see that we have a bunch of reviews. So that's all good. These are two external endpoints. They could be living locally at your computer, but also somewhere else, completely else, some IP far, far away. So what's the point of this? Well, right now we got some endpoints over here and an endpoints over there and a GraphQL API, and no one talks to each other. Awesome, right? No? Yeah, they should probably talk to each other, am I right? Yeah, so we can easily integrate this by going into the resolver file for GraphQL and just say, actually talk to these two endpoints instead. So make sure you do a fetch towards this endpoint and in here as well. And suddenly everybody's happy and the GraphQL is merged together with your microservices, and you should have an image looking like this. Right? Awesome. So this kind of scales, because we can keep on extending our GraphQL API all day long. So what about hosting? Serverless. Few hands, I think 30% of the crowd have been using serverless. Serverless is a way to host GraphQL APIs. It's not the perfect way. What makes serverless a possibly good candidate is that the fact is you're building a GraphQL API over a big services landscape, which means that all of those services might not be aware that you're actually building a GraphQL API on top of everything. So why is that relevant? It means that maybe, just maybe, that GraphQL API don't need to be up all the time. Maybe the uptime is not 100%, but maybe 20% or even less. So I want you to consider the combination of serverless and GraphQL API for that reason, because serverless is not up and running all the time. It's a very cheap option to just take data from here, from there, and from there. Now, I talked a little bit about microbilling. I just wanted to show you from the sake of Azure. A lot of you are on AWS. If it's not that cheap on AWS, then go with GCP, right? Oh, he's still awake. Awesome. Wasn't sure. Sometimes I do need to tell a joke, but you might end up sleeping anyway. So, should I make everything serverless? Kind of depends, am I right? If your code is called all the time, 100% uptime is probably a good idea. Serverless is a bad idea. If you got seldom used code, you can use some kind of instrumentation inside of your app and say, maybe this part of the code actually don't need to be here. Maybe it should be a microservice, and just maybe I should use serverless for that. And of course, never used code. Anyone knows what to do with that? Thank you. Thank you. All right, so I got 2 minutes left. Hyperspeed. Okay, so the function secret sauce in most offers when it comes to serverless is the fact that, one, we got a bunch of useful triggers, which means there are different reasons why our code is starting in the first place, which could be blob storage, maybe some kind of database where there's an insertion or deletion, or maybe there's a new message on top of our queue, or there's a timer that just says at regular intervals, please call this bit of code for me. And yeah, bindings. Is there bindings in AWS, or do you know what I'm talking about? Nah, okay. So bindings is the way to make life easy for you. That means a lot of connection code that reads data and writes data is written for you. Bindings simply mean we have a configuration file. So if you just say, I've got a database here, an Excel here, I'm going to make magic. Black box, you don't need to care. I'm going to connect these two data sources for you. So in this case, you just specify with a connection string, here's my database, and I want to read from it. So once my code executes, I want a bunch of records in, right? I'm at the moment of execution of my code. I got a bunch of data. I'm happy. But I also want a reference so I can write. So that means when I'm running my serverless code, I want the ability to just easily populate this reference and say, insert, please. Because when I'm writing serverless nowadays, usually my code never ends up to more than 10 lines of code. And that's pretty much what you want, right? I have my data, do some manipulation, save or create whatever, right? Should be easy. Different ways of authoring, of course. You got the Azure portal, but you also have VS Code with WebStorms and different extensions in it. And yeah, at the bottom of things, we got the Azure Functions Core, which is a library that you kind of need at the bottom. That library installs a executable. That executable is callable in CI/CD scenarios, because that's what you want, right? You want to be able to create your functions, run them in different ways. There are different options for Mac, for Windows, and Ubuntu, so I think that should capture most of you, unless you're on a very exotic OS. No? And of course, there's a VS Code extension that's going to make life super easy. Let's have a look at a demo to see how easy this actually is. And I'm probably going to be thrown out of here, but I don't care. I want to show you. Okay, so now we're looking at trying to scaffold up a Azure Functions project. You should note that probably in Amazon, I think you just have functions. You don't have the notion of an app. But in Azure, you have the notion of an app, and that app contains X number of functions in it. First thing we're going to do is to select what type of code language, which is JavaScript. Then when we first create our first function app, it's going to ask, you probably want a function in there as well. So what you want that function to be triggered by and what you want to call that function. So we call it get, and we got different authorization levels, which is anonymous, function, which means you're using an API key, and admin means you got even more security added to that. We're going to go with anonymous because we are wild and crazy. This is a demo. All right, so we got a piece of code here on the right, which essentially tells us we got two different input params, context and request object, and from the request we can read queries, but also from the body. So depending on whether we are getting or posting, we can find our data. Lastly here, we populate this context res object, and this is just an HTTP response that comes back. There's no actual return statement, but rather populate context res and everybody's happy. Set the body property because that's what people are going to see. And you can also override the content type, so it goes from text to JSON or whatever else output type you need. As I said, we got the HTTP trigger, anonymous. These are options that we did in the beginning. We can easily change those to whatever we want them to be. Get and post, we can also change that. So if we just want it to be a get, it's a get. If we want it to be a put, and so on. Now, start debugging, of course. Debugging should be easy and nice. So we fire this up. This compiles, and at the end of compilation, it's going to give us an endpoint. Then what? We got the localhost 7071 API get, so we should go to a browser and try that out. Now let's give this a param. So say name Chris. Now what? We're able to hover over context and rec, and we see that it's fully populated, and our debug experience is quite nice in VS Code thanks to the extension. And that's pretty much what I wanted to show in the context of serverless in VS Code. And I'm getting angry looks, no? Happy looks, somewhat. 1 minute. Okay, so integrating GraphQL in our serverless API. We've seen all the parts, right? We've built the GraphQL API. We are talking to different microservices endpoints. We have seen how we can scaffold up our serverless app. We're going to do pretty much the same. What we need to understand is that we need to move our GraphQL code inside of the serverless app, right? So we've done all the hard work. We have defined the schema, our resolver, everything that we could possibly need. Now we just need to scaffold up our serverless app. And we need to proxy all the different requests that comes into the serverless and just say, here GraphQL API, you know what to do with this. Take this and give me a suitable response back. So we integrate our GraphQL API with serverless, and there's another demo. Surprise. So let's check the function config. Right now we have scaffolded up a serverless app with one function. It's called GraphQL. Just what you looked at, we just named it differently. We have also created this subdirectory API, which contains app.js that instantiate our Apollo server, our resolvers, and our schema. All of that is in there. That's great, right? So that's the easy step. We just move the code. Now what? Let's see. Okay, so we had a look at API. We want to look at this one. Aha! We are doing a require from the GraphQL API. And of course, we need to provide query. That's one of the conditions, right? We need to expose some kind of query so people can send that into our serverless API. And we also have this server execute operation. This is what we're doing when we're passing whatever comes from the outside into our GraphQL API. And Apollo server, GraphQL, node fetch, all of those library dependencies. Of course, the serverless project needs to depend on those as well. Because otherwise it wouldn't be able to build everything together. Okay then, now what? We get a endpoint, and we're able to go here and specify our GraphQL query. So we ask for reviews, we ask for products, and a bunch of other things. We see that all our nested queries work. We also see that they are talking to the microservices. So we see how everything now works together. And you're like, he missed me at GraphQL. I mean, fair enough, this is a 1-hour talk, right? I'm not going to show you the deploy part. We don't have time for that. But what I will show you is another summary slide. In theory, you have learned about microservices, Node.js Express, and Docker Compose. I think most of you said yes to Docker from the get-go. If you want to see this at probably quarter speed, I got this aka ms GraphQL-workshop where you can do this yourself. It's completely free. It's hosted on the internet. You can do this at your own time. If you want to give me some kind of PR, make it better, please do so. I very much welcome any contributions. I also have a video tutorial where you can either mute me or have a look. It's up to you. dev2/softchris. This is where I write most of my material. And I got a very long listing of Docker and Kubernetes. If someone is interested in that, it's like 15, 20 articles. Kubernetes. Who loves Kubernetes? Who are confused by Kubernetes? All right. Okay. Thank you very much. Great to see all of you. And yeah, any questions? Make it quick, right?
No time for questions.
No time for questions. Yeah. We knew that, right?
Yeah.
I'll be here to the end of the session.
I have one question. I'm being generous.
Yes. Access control? Oh, you mean like authorization levels and... yeah, so with GraphQL, it doesn't have an opinion on security at all, which means that you kind of need to build that in. So yeah, that answer kind of sucks, but that's really it with GraphQL. It's just a query language more, and it's up to you to solve that. But the way I would solve it is to have some kind of parameter in that you would need, like a token or something, and say, the JWT or something like that, and you're able to say, can this person actually do this at this nested level, and so on. There are also different ways to create different queries so that depending on who is actually arriving at your endpoint, you can just make sure to expose different versions. So in one version, you can have a query that only allows for 3 columns, and in the more allowed level, that could be like 10 columns. So there are different ways of putting security before, but also inside of the actual GraphQL implementation.